In this experiment, I found out how and how much the angle of solar panels affects how much voltage it produces. I used this solar panel since it had a stand that may come in handy. We measured different angles at noon because the sun was right above us. We measured angles 0 to 90 with 15-degree intervals. 0 degrees would be direct sunlight, which means it was coming directly from the sun, and 90 degrees would be all reflected light. So it was coming from here, and reflected light would be light bouncing off of other objects. One shocking thing we found was that you can lose up to 15% of energy derived from your solar panels if you do not place them correctly. That's a surprising amount, especially if you've installed rooftop solar panels. I also made a robot that measures the voltage at various angles and then goes back to the angle with the highest voltage. I made this with an Arduino board, which is around $30, 2 servo motors included with assembly, which are about $20, a small breadboard, and a voltage regulator. So, before I show you how the robot works, I want to show you its code. So this is my code for the program, and this includes the servos, and this defines one of the servos. It's my x-axis servo, and I've set the initial position for it at 180, and I do the same thing with the y-axis servo, and I set the initial position for 180 degrees. And the voltage delay is before we take another voltage reading, we delay this much. We delay 20. So, and for this one, the position delay, that is before we move on to another position, we delay this much. In my void setup, it attaches both pins. It attaches my servo X to 12 and my servo Y to 11, and it begins the serial. So there's a serial monitor right here, and that is used to see if something is going wrong. I can see on my computer where it's going wrong, and then it prints hello terminal just to make sure that it's actually working. And this is what it does before, and it prints it out before it goes into the while loop. I mean the void loop, sorry. So these are the three values. So volt 1 is analog read pin 0, and they all read the same thing, and then they average it out, and then it returns the average onto the serial monitor. And here's my void loop. So my X position is 0, and my initial volt, my volt, and my best volt. So my best volt is the best voltage that has come, and then so if that happens, then it records best X and best Y. Not right now, but later on in the loop. And volt is just the measurement of the voltage. So here we start. So here's my first loop. It says while X position is less than 180. So it's starting and it's going all the way to 180 in a full circle, and then so it writes the X position onto the serial monitor over here, and then the voltage, and then it reads the volt, and then it goes back to the function read voltage, and then it sees if volt is better than best volt. So after that, it makes sure that best volt equals volt, and then it makes the best X position the X position, and then the Y position the Y position. And so it prints serial print with a line best volt, then best X, then best Y, and then it prints a series of lines. Then it adds Y position. So Y position increments. So if there's 180 degrees, then after the x-axis is done rotating 10 10 10 all the way to 180, then this will rotate 10, and that'll keep on happening until x plus and y plus become 180. And then after that, over here, it goes and then it says my servo, and then it writes the best X, it writes the best Y, and then it just goes right there. It just goes to the part with the most voltage. Now that you've seen the code, let's see this robot in action. Since the sunlight is coming from this direction, the solar panel on the robot should face this way. Now let's see it work. It's measuring the angles at 10-degree intervals right now. As you can see, it pointed directly to the direction where the sunlight was coming from. So this proves that this robot could go back to the angle with the highest voltage.